In this lesson, we're going to review how to solve systems of equations algebraically. You have looked at solving systems graphically, and there's several ways that the system could play out. If we're talking about a linear system, it's possible that your two lines intersect at a point. This has one solution. It's also possible that your lines are parallel and that there is no solution. Or it's also possible that your lines coincide, meaning one line falls directly on top of the other. And in this scenario, there are infinite solutions. But we're going to look at how does this play out when we have lines that don't intersect at nice integer values. For instance, if you look at the two lines on the screen, there's definitely a point of intersection, but they're not intersecting at nice integer values. The best you could do would be to estimate the point of intersection, and frankly, that's just not good enough. In mathematics, we need the ability to come up with exact answers. So there are two methods that we're going to review here. Substitution and elimination are the two algebraic methods for solving a system. So we're going to solve the system on the screen two different ways. So the first thing you want to do is solve for one variable in one equation, and this is going to be your choice. So my tip is I scan both and I look for one variable that perhaps has a coefficient of 1 or -1. So when I look at this top one, I'm choosing to solve it for y. So to do that, I subtract 4x from each side, which produces -y is equal to -4x plus 20. Then I would divide both sides by -1 to get y is equal to 4x minus 20. Now what I'm going to do is I'm going to substitute this equation into my opposite equation. So my other equation is -2x minus 2 times y equals 10. So you notice that instead of writing y, I just opened up a large set of parentheses. And since in step 1 I know that y is equivalent to 4x minus 20, I'm replacing y with 4x minus 20. And now I'm solving this new equation, which is just Algebra 1 skills of combining like terms and distributing. So I begin by distributing the -2 to get -8x plus 40 is equal to 10. Combine your like terms. -2x minus 8x is -10x plus 40 equals 10. Subtract 40 from each side to get -10x is equal to -30. Divide both sides by -10 and I get x equals 3. I'm halfway there. My solution, I know, is an ordered pair if they intersect. So I know that this is 3. For x, I need y. To get y, the easiest place to plug it in, I know x is 3. I could plug it back into any original equation, but if I plug back into step 1, it's fastest. This gives me y equals 4 times 3, just switch colors there, minus 20 would be 12 minus 20 or -8 for y. So my ordered pair, where these two lines intersect, would be 3, -8. We're going to redo this problem now using elimination. And my tip is multiply to create opposite x's or y's. So if I look right here at my x's, I have 4x and -2x. They're not exactly opposite. If I look at the y's, -y and -2y. So I have two choices here. I want to create opposite x's or opposite y's. I'm going to choose to create opposite x's, I think. Again, it's my choice. I can do this any way I want. So if I have 4x at the top, if this were -4x, it would be its opposite. To make that be -4x, I would have to multiply the bottom equation by 2, and I'm going to multiply both sides by that. So I'm just going to recopy the top one, and I distribute the 2 in the bottom one to get -4x minus 4y equals 20. Now I stack and add, meaning just set it up like an addition problem and add vertically. So -4x plus 4x, it's eliminated. The whole point of doing this. -y minus 4y, or I could say -y plus -4y is -5y. And 20 plus 20 is 40. Now I have a very easy one-step equation right here. How do I solve that? Divide both sides by -5, which produces y is equal to -8. So I'm going to write that in my ordered pair for my solution. And I need to get my x value, so I can't avoid substitution altogether. I'm going to go back to my original equation, the 4x minus, I'm going to plug in -8 for y is equal to 20. I chose to plug in to the top equation. You can choose whichever one you like better. So that's 4x plus 8 is equal to 20. I subtract 8 from each side, which gives me 4x equals 12, and divide both sides by 4 to get x equals 3. So again, I get the solution of 3, -8. It's a good idea to check this out on the graphing calculator, which I'll show you how to do, but in order to graph these on the graphing calculator, you must have both equations in slope-intercept form. So the first one we already converted in substitution. I will do the second one now, so I'm going to add 2x to both sides, gives me -2y equals 2x plus 10. Then I divide both sides by -2, and that gives me y equals -x minus 5. So here are my two equations that I'll now put in the graphing calculator. To see the point of intersection in a linear system, enter both equations by hitting y equals. Clear out anything in your calculator, and we're going to enter 4x, which is next to the alpha button, minus 20. Going to enter my second equation. I missed y1, so I'll just go up here and put -x minus 5. So they both have to be in slope-intercept form. Now, my window, you can see here, is definitely not my standard viewing window of -10 to 10. The easiest way to get that is to hit zoom 6 for the standard viewing window. And it will automatically graph, and you'll see your two lines. Now, algebraically, we got that these should intersect at the point 3, -8, and it kind of looks like maybe they are, but there's an actual intersection tool to determine this. So if you hit second trace and select 5 for intersect, it's going to ask you your first curve. So what you do is you need to be to the left of where these two things cross, but to the left on your first, on mine, on my blue line. I know it says curve. Get real close as you can, but you're sure that it's not intersecting. I hit enter. And now I'm on the red curve, my second one, and I need to move my cursor to the right of where they intersect. So we know they intersect here and it's to the right, so that's a little too far. I can move it a little to the left. I hit enter, and then it's going to say guess. Yep, I want you to guess. And there it is, 3, -8, just as we knew it should be. So in any type of assessment, I would absolutely use my graphing calculator to confirm points of intersection.